Okay, welcome to another week of physics. And the first Monday Night Football of the year featuring the Oakland Raiders and the Los Angeles Rams, two teams that had those names years ago before they both moved around. And I'm, I don't know, guardedly optimistic we won't get blown out. So today is just going to be a review, hence I'm not going to have students come and work a problem at the beginning, nor am I going to have students work a problem at the end, because I'm just going to be reviewing today. Some things just to make sure that we're all clear. Number one is we cycled once through the homework groups, and so now the homework groups have changed. Now I'm hoping that you guys are getting into the habit of getting together with your homework group and actually going over problems together. The idea is for you to have other people to work with. And I know you have your normal friends you work with, but I want things to switch around just so you get different perspectives. So you're probably wondering, I know I sent an email, but if you didn't look at that email, then you're probably wondering, well, who is in my group? And apparently it's different for students as compared to teachers to see the groups. For me, it's easy. For you, apparently, at least I was trying to look at it from a student's perspective, but not being an actual student, it's not as easy. But I can just click here to groups and go to overview. Yes, go to overview. And voila, it shows me all the groups. So you can see everybody who's in your group. And I'm not going to read all the groups out loud. I figure you guys do have the ability to read all on your own. But identify who you're working with. And these groups will actually be effective for you starting Wednesday, because Wednesday you will have the homework. I don't remember what number, if I changed the number or left it. We dropped one homework assignment. You noticed that, right? And there's a homework assignment that's due on Wednesday that has one problem that's applicable for the test. And then the other four are new material on the forces. And so the problem I choose on Wednesday would be one of those ones from the new material on the forces for a group to do. So that would be the first new group activity. So I want to make sure we have that covered. And then I also thought it might be good to remind everyone that we do have an assignment coming up here. Let's see. Assignments. The assignments list is coming up. And once again, as quick as can be, we can look at the list of assignments and we see that a new type of assignment, the first scrapbook submission, is due tonight before midnight. So you can go to the syllabus on Moodle and click the link there for my sample that shows 2 entries. You need 5 entries that are covering ideas from the first 3 chapters. Yes?
I noticed when I was looking through the syllabus requirements for it that you wanted to put the page number of where we found stuff in the textbook.
Okay. I thought I clarified that, but maybe I didn't change all the wording. Yeah, put the section.
Okay, yeah, because I didn't see one.
Yeah.
And I was like, I don't want to buy another book.
No, I bought a book so I could find the page number. Yes, put the section.
Okay.
Okay, Mira had a question.
So just to clarify, we don't have an assignment due this Wednesday with what you were just talking about. We have one problem.
No, there's a homework assignment that's due on Wednesday. It's the one that was originally due Friday that I postponed to today and then realized there's only one question that's relevant for the test. The rest of it is not. And so I postponed it again to Wednesday. Okay. Leslie had a question?
First you postponed.
I postponed it twice.
Oh, so you postponed it to Monday and then you postponed it to
Wednesday.
Oh, that's okay.
And that.
Sorry, I'm like excited now. Okay, and
I'm excited.
and the scrapbook. So, for instance, if it's like chapter 2, then you put chapter 2.3, like the section 2.3.
2.3, or if it's subdivide 2.3.1. I don't think they are, but yes. Okay, Madison.
How long on average do your tests usually take?
Well, I am changing the format once again this year, so I honestly don't know. Because they're all multiple choice, you could answer all the questions in 5 minutes. Chances of being right on them is not so high. Typically what I have observed over 23 years, 24, I haven't counted, is that most students answer everything they know within the first hour. And then they spend any additional time trying to figure out things that they can't figure out. And you could quite literally spend 24 hours if you don't know how to do a problem. And so then it just becomes a process of attrition. So you have 2 hours within which to complete it. So I hope that everyone is done well before the 2 hours. With the change, you have multiple choice. Last year I gave them answers, but they had to show the work. Now it's just multiple choice. They don't have to show the work, which takes away. Some people wrote books, and it should take away the time of the writing for the explanations. So it should take less time because you don't have to write the explanations. DJ.
Can we write on the text, or do we need to bring a separate?
Oh no, you can write on the text. I'll give you scratch paper as well. There's going to be a scan sheet like we did for the pre-test where you'll bubble in your answers, but then I'll also have you turn in the exam because if there's a problem that you didn't bubble in, I have something I can go and check.
And to clarify too, you said calculators are not specified.
Right. You can use a calculator of any sort that is a calculator. You cannot use a smartphone as your calculator. Smartphones, smartwatches, those you can't have with you for very obvious reasons. Michael.
So, the equation part of the test, they also multiple choice that you just have to work the complete and use it like a separate sheet of paper to work them out, and then with the answer.
Yeah, you'll have a test form, you'll have some scratch paper, and you'll have a multiple choice form to fill out.
Okay.
Yes.
So then when it comes, you said that when it's like adding vectors or something, you'll probably just put like images or something, since it's all gonna be multiple choice.
Right. The adding vectors, I will have figures and say which one is correct for the graphical. Any other questions while we're in question answering mood? Nah. All right. Then a review of what we've learned. So we just chapters 1, 2, and 3, not chapter 4. I've lectured on chapter 4, I guess only one day maybe. The idea is to make sure that you've had time to digest the material, to think about it before it becomes the test. So it's just chapters 1, 2, and 3. Chapter 1 was the introduction. It has things, we'll just talk about it. First, pull out a piece of paper. This is a non-graded quiz, right? This is not something that you have to share your paper with somebody else and they're going to mark a grade. There's nothing you're going to turn into me. It's just so you have a chance here to write down what you think to see how prepared you are on some of the basic knowledge things that will be on the test. So these are the type of questions that would be in the knowledge section of the test. I think I have 6 of them here.
Can I put this on my laptop instead of a paper?
What?
Can I put this on my
Oh, sure. Yeah, like I said, it's not grade. You don't have to give it to anyone. I just want you to put down what you think rather than just see it and have it pass by your eyes. And then after we go through these, then we're going to go through the answers as well. So, okay, going on to the next one. What is the SI base unit for distance? I guess I should read them out loud and then just move on. Parsec, light year, kilometer, meter, centimeter, mile, or foot. Next one. What is the SI base unit for mass? Newton, kilogram, gram, slug, carat. Number 4. How many significant figures are in the quotient of 539.35 divided by 600 equals 0.89891667. Select all answers that could be correct. 1, 2, 3, 4, 5, 6, 7, or infinite. How many significant figures are in the sum of 539.35 plus 601 equals 1140.350? Select all answers that could be correct. And once again, 1, 2, 3, 4, 5, 6, 7, or infinite. And I believe this is the last one. For a two-dimensional coordinate system, what spatial relationship must the x and y directions have? They must be parallel to each other. They must be 45 degrees from each other. They must be 60 degrees from each other, or they must be perpendicular to each other. So, unless I'm really dumb, that's the end. I shouldn't say really dumb, because what if I'm wrong? Unless I am in error. Yeah. Okay, now we're going to do a review, and we'll come to each question very quickly. In chapter 1, we have the scientific method. The scientific method we are examining mostly in the lab. So you've gone through 3 labs now. You have the experience of number 1. What's the first thing you do in the scientific method part? Wait. Observe something that's interesting. Clayton's got another test coming up on Wednesday where he's going to have to do a lot more with this. Okay, so you observe something interesting, something that you see in life. Step number 2, hypothesis that has to do 3 specific things. What are those 3 specific things?
Predict.
It has to make predictions that can be tested.
Explain why something.
Has to explain why the thing you observed occurred. Right? It's no use if it doesn't give you an explanation of this happened.
It's testable, like you don't have those.
Okay, that's in the same category of what he said. It has to make predictions that are testable.
Yeah.
Okay, one more.
Based on other scientific knowledge.
Based off previously existing scientific knowledge. Not just, well, that's the way I feel. Seems reasonable. And then the way I've been talking about it, what's the last step? Or no, there's 2 more steps. What's the next step? 3. The what?
Test.
Yeah. You conduct a test of one of the predictions. And then the last step, the way we've been talking about it, in your lab, you're saying if it either passed or failed the test, if it confirmed your hypothesis or if it refuted your hypothesis. What do you do if it confirmed your hypothesis? You go back and do more tests. You don't say, woohoo, I was right. You say, woohoo, prediction number 1 was right, let's go try something else and see if prediction number 2 is right, 3. What if you refute it? What if you show that it's wrong? You got to go back and revise the hypothesis because now you have more knowledge. Now you know more of what it's not, and each time you cross out something it's not, you should be getting closer to the correct. And so the scientific method is a process of getting closer and closer to correct knowledge about the universe. So if you take the best scientific understanding of something today, it's not right necessarily, it's the best we know. And if you go back 100 years, what the best scientific knowledge was then is quite different in many areas than it is today. So what they thought was true then, now we say, how naive. Just because we've done a lot more experiments and proved a lot more things wrong. Okay, now with the units. What were your answers? Seconds. One of these things is not like the others. Which one's not like the others?
Parsec.
Parsec. What is a parsec, friends? I call you.
This has got me confused on that. Like, is it length or time?
You did 12 parsec.
No, it's only one. It's only one. If you find somebody that's honest, they will tell you the same thing they tell you about Back to the Future. They simply didn't know that a parsec was a unit of distance. And so they used it incorrectly. If you talk to other people, they'll say, oh, no. Because of the warping of the space-time continuum, the length contracts if you're going fast. So by making it a shorter length, that means he was just going super fast, and it was a statement relativistically of saying the distance was shortened to this amount. That's really a stretch. So a parsec is a parallax arc second. Second in this case is a measurement of angle. And so it's the distance for an object to have a parallax angle of a second. It's a little more than that. Okay, next one. What is the SI base unit for distance then? Parsecs are distance, so I put them here too. Okay, the meter. The meter. Anybody remember the definition of a meter? It's not going to be asked.
Is it like 1/1,000,000th of the distance to the pole from the equator?
It's something like that, yes. And I don't remember the exact number. It could be a million, could be 100 millionth. But it was a fraction of the distance from, well, let's think about it logically. It's got to be on the order of like 10 kilometers, 10 kilometers, or not 10,000 kilometers. So that would be 10 million. I don't know. So yeah, that's the meter. It used to be, after that, it was the distance between two marks on a bar. And now it's the number of a certain specific wavelengths of light. Okay. What is the SI base unit for mass? It is not C. That one is a little confusing because it has a prefix on there. Kilogram. Now make sure you know prefixes. Make sure you know. Make sure you know those prefixes. So very quickly, I know I didn't lecture on these, but you have them in the textbook and you're reading. N, what is N? How do you say N? No. What does it stand for? Nano. Okay, N is nano. And what does nano mean? It's in the -9. What is this symbol? Okay, I'm going to write micro. Somebody said it correctly. It's mu. It's the Greek lowercase m. I started to write mu and then decided I was going to go ahead and write micro because that's how we say it, right? We don't say mu meters. We say micrometers. And micro is 10 to the -6. M is?
Do you want us to know the prefixes?
Yes. C is? Centi, and that's 10 -2. K is what we just had here. 10 raised to the capital M. And that's 10 raised to the? Pretty easy with the powers, right? Even if you didn't know, you could follow a pattern. Capital G is giga.
We don't need to know decibecker, right?
No, you do not. And giga is 10 to the? And once again, Back to the Future, he says giga instead of giga because nobody on the set knew what giga was. Great. Scott. 1.21 gigawatts.
Oh.
Which is also a power. I'm not sure. Anyway. Make sure you know those prefixes because they could just be in a problem. Or you could have a question that actually asks you, put them in the right order from smallest to biggest, or what does this mean? Okay, now, Leslie laughed at one of these answers. Which one did you laugh at, Leslie? You did. You said one out loud and laughed when we did this.
Oh, slug.
Yes. Anybody know what a slug is? Okay, there are multiple correct answers. You could have said it's, the mascot of the UCSC, it's the University of California, Santa Cruz, slugs. Nathan answered with the one I was looking for. There's other answers, but the one I was looking for is the slug is the British imperial unit of mass. Mass is a measurement of how much stuff is present. We measure in kilograms in the SI system, the metric system. And in the British imperial system, they use the slug. A carat, I don't even remember what a carat is. I know it's used to measure diamonds and gold and whatnot, but what it actually means, I don't remember if it's a weight or a mass. But a Newton is not a mass. A Newton is the unit of force. So that is not like the others again. All right. moving on from now this is the end of chapter 1. We're still in chapter 1. We have the terms of accuracy, precision, and significant figures. Significant figures, you're definitely going to have at least one question on. I won't say some, but at least one. So you had 2 questions here, and select all that could be correct. What should we select here? Okay, 1.
Or 3.
Or 3.
I was talking to Dr. Clark about this the other day, and he was mentioning that, like, you could either say it's 1, you could even say it's 2, or you can say it's 3, and then he said, yeah, that rule's kind of funny.
We don't know where the
Yeah,
decimal necessarily is.
yeah.
Right. There's one other possible answer here. Those 3 are all correct. There's one other possible. It could be any one of these because 600 could have, 600 could have one significant digit. It could be 6 with both zeros being just placeholders. It could have 2, 6, 0 with the last 0 placeholder. It could have 3 with both zeros being significant, or it could be infinite. It could be that 600 is a cardinal number.
Why did we circle 5?
Huh? I circled 5 because when you do division, the number of significant digits in your answer is the smaller of the number of significant digits in each of the 2 numbers you divide. The same is rule for multiplication. So the 539.35 had 5, and so that's why 5 is there. 4 is not an option because 600 is definitely not 4. And of course, 6, 7, and infinite are not an option because 539.35. Yes?
I was going to ask something that I realized that you probably can't answer.
Okay. Okay, so make sure you know the rule for division and multiplication. Number of significant digits in the answer is the smaller of the number of significant digits in your 2 original numbers. Now, addition, subtraction. What's our correct answer or answers here? Four is the correct number. The rule for significant digits. Now, significant digits, remember, is a way of tracking uncertainty propagation. It's not perfect, but it's based on percentage error. And when you're adding and subtracting, you look at what is the least significant digit in each number. And so if you look for which one's the least significant digit in each number, you say, well, the 1 is the least significant digit in that number, and the 5 is the least significant digit in that number. So the 1 is in the units, the 5 is in the 100ths. They say, which is bigger, units or 100ths? Easy answer, units is bigger. And so the answer is significant to the greater of the least significant digits, so the answer is good to the units as well. And I chose numbers that added up, so it just went over 999 and gave us one more digit that was significant. Now, in real life, of course, the difference between 999 and 1,000 isn't very large. But significant digits, that would be an order of 10 for the significant digit importance.
Say that again, please.
Explain why the answer here is 4? Okay. I will, and I will do it the way I usually write it out so I won't make a mistake. I stack the numbers. And then I identify the least significant digit in each number, which would be this digit and this digit. And then I say which one of those is in the largest column. Right, the units column is a larger column than the 100ths column. And then I just draw a dashed line to correspond with that digit. And in my answer, whatever falls to the left of that dashed line is going to be significant. So my answer, can't write when it's zoomed. And of course, there should be no 0 at the end. I put that on there as a distractor. So everything that's to the left of that dashed line, the 1140, is significant. Everything to the right of it is not significant.
So I'm assuming on a test, if you were to give us like the one before, where it had like the zeros, then you would want us to do something like that, circle all those?
Yeah, I would either have you circle all of them, or I would do something to make it so it was not ambiguous. Right? If I put a decimal point here, then the answer has to be 3. Or if I put a bar over here, the answer has to be 2. Or
you could put that question on those 4 as the answer choice.
those 4. Choose a correct answer. Emily.
When we work out a problem, how close are your answers? Like,
My answer should be correct.
I mean, like the options to each other.
They should be distinguishably different. Except for in cases, there will be a few cases where you're looking for, did they do the calculation right? So all the numbers are the same except for like the last digit or so. But in general,
Because there's multiple choice and like we're off a few digits. How
well,
How much error?
yeah, and unless it's a case where the answers are stacked tightly together and I'm looking to see if you could get the exact answer, if you're out by a few digits, I would assume you have the right number and it's round out there.
okay, but since it's multiple choice and we don't get graded on work, how's your assumption? Like, that's where I'm leaving it.
Well, like I said, there's only 2 ways that it can be. Either your answers will be significantly different, in which case, if you have round off error, you'll easily go to the right one, the one that's almost exactly yours. Or the answers would be really close because I'm looking to see if you could do the precise calculation. In which case, it's if you chose. So in both cases, to my thinking, based on the goal I have my answers set out, and if you chose the correct one, then your thinking was correct. That's at least the way I'm thinking about it.
You'd be like our homework.
Yes, it'd be kind of like the homework. All right, now moving to chapter 2. I forgot we don't have a problem. I actually do have 20 minutes left. Chapter 2, we started dealing with kinematics, with steadying motion. So we have things like vectors and scalars that we had to learn about. And the names of terms, these are not, by the way, sections of the book. I started rearranging them to make them match sections. And I realized, well, that's just going to take a whole bunch of space. Let's go with the general ideas. So then we have the names that we use. Displacement is the vector between starting and ending positions, whereas distance is how much ground was traveled. Time, pretty obvious. Velocity is the speed and the direction of motion. The acceleration, well, it's a vector. Speed is a scalar. Remember, velocity is change in displacement over change in time. Of course, you're given that equation, but you need to have a fundamental understanding of it to use it. Acceleration, change in velocity over change in time. So a change in the direction of the velocity is an acceleration. Then we have the kinematic equations, which you're going to be given. Those kinematic equations, you have the 4 basic equations. When you're using them, for Physics 151 students, every problem will have, if you're going to use a kinematic equation, it's going to be constant acceleration for a block of time. You may go from 0 acceleration to 9.8 meters per second, for instance. I'm holding something in my hand, I drop it, it goes from 0 to 9.8 when I let go. But you're not going to have a changing acceleration with time. Physics 251 students, yeah, you'll probably have a changing acceleration with respect to time because you guys know how to deal with it. So those kinematic equations require, you need to know this, they require a constant acceleration. If the acceleration is changing, those kinematic equations aren't correct. And then you need to be able to use them, which primarily is identify what variables you have and what you're looking for, find the equation that matches the units. At this point where we don't have much physics involved, it's just look at the variables. Later on, it'll get more complicated because, well, it always does. That's life. Make sure you have strategies for solving problems. So I'm going to go through a strategy, steps to do in solving a problem, and that you can do problems for falling objects. Chapter 3 is just going from one-dimensional motion to two-dimensional motion. So there's really not anything new added to chapter 3 except adding another dimension. So we had our last question here, going actually to chapter 3 idea. For a two-dimensional coordinate system, what spatial relationship must the x and y directions have? They must be perpendicular to each other. Why is it important to break your motion up into two perpendicular directions?
For right angle triangles.
It's actually not for that, although it's very useful for that. It's because the motion is completely independent. So if I break it up to directions like this motion is completely independent of that motion. Right now, this seems ridiculous to choose for my coordinates. What makes sense to choose for my coordinates? Vertical and horizontal. Why? The answer I'm not going to ask you right now. I'm just going to let you know, because in the next chapter it will become clear. We want our coordinates to be such that all of the acceleration is in one coordinate direction. And so if you drop something, all of the acceleration is in the vertical direction, hence vertical makes sense. And then the horizontal direction has zero acceleration, which takes one variable out of your kinematic equations, makes life easier. That's why we choose vertical and horizontal. We could work every problem we have using coordinates like this. It would just make it a lot harder. And as unobvious as it may seem to students, in physics we're trying to make things as easy as possible. That's why we don't do that. All right, so steps to solving a problem. This is a very general set of steps. This applies for virtually any problem. And step number 0 that I forgot to put there is draw a diagram. Now on the test, I'm not going to be grading on diagrams. Usually that was 20%. You get 20% just for drawing all the diagrams in. Or was it 30%? It depends on the year. Because diagrams are important to visualizing it. This year, I'm just assuming if you get the right answer, that you must have used a method that allowed you to visualize it accurately. You might, with many problems at this step, say, I can visualize that problem without drawing any figure at all. But as we move forward, we'll get to situations where most people can't visualize the problem without having a picture to get the pieces in their mind. So draw a diagram, determine what physical principles are involved. Right now, physical principles is confined to kinematic equations. With chapter 4, we start to have dynamics. We have actual reasons for these things. But up through chapter 3, the only thing we have is, well, I have an equation. It really doesn't fit into the topic of physics, believe it or not. It's more about math at this point. But with chapter 4, when we start saying why we do dynamics, that's clearly physics then. So right now, the physical principles is just a blip in the steps. But as you move forward, it'll become important. Then you want to list what's known, and notice this, or can be inferred. Things like, oh, it's on the Earth, so it's going to have a downward acceleration of 9.8 meters per second squared due to gravity. Or, oh, it's sliding and stopping, so there must be friction at present, even though it doesn't say friction. We're going to assume no friction unless there's some reason like that to believe there is friction. So make a list of what's known and what's inferred, and likewise identify what you're looking for. Yes?
So wait, when we're seeing whether it's friction or not, like, I don't know, that just kind of confused me now. So it's like you're moving something, and how can you tell whether you need to use friction?
Well, let's take the problem we did in class Friday. I think I was talking with Emma, she was asking me questions about it is there friction? Well, the person was pushing with a constant force and it was moving at constant velocity. those two statements together means that there had to be a force opposing the motion. Otherwise, it'd be accelerated. Because Newton's second law says, well, let's go with Newton's first law, that an object stays in constant motion, which means constant velocity, unless there's an unbalanced force. So since it was constant velocity, it had to be a balanced force, and that force is zero. So if I'm pushing this way, something has to be opposing me. And without anything mentioned, I just assume, well, it must be friction that's opposing me.
Okay, so then if the problem said that it was accelerating, then we wouldn't have to worry about that?
If it said it's accelerating and we don't have any numbers on it, I'm going to assume there's no friction. If it says it's accelerating and it gives me a number, well, then I go to Newton's second law to determine if it has friction or not. Okay, that's not for this test, though.
Okay.
Okay, find an equation or set of equations that can help you solve the problem. What strategy did I give you to find the equation to use? Look at the sheet of equations and, yeah. For instance, if time is not a part of your problem, you don't know time, you're not looking for time, go to the equation that doesn't have time. See if that works. If distance is not a part of the problem, then go to the equation without distance in it. So that's a way to eliminate equations. Of course, most of the time you have all of the variables, and then you use the kinematic equation with all of the variables. So then finally you put your numbers into the equation and solve it. And then when you're done, check your answer to make sure it's reasonable, to make sure its units are correct. For the test, you'll probably have at least one question that just gives you an equation and asks you what the units are for the answer. And so you'll have, mass times speed squared. What are the units? And you'll say, mass is kilograms, speed is meter per second, so kilograms times meter squared per second squared. Right, so make sure you can do that unit analysis. Make sure when you do an answer, unless you're running out of time, make sure you check, are those units the right units? Okay, so practice problem. Because now we're to, actually, before I do the practice problem here, let me get to, here's the chapter 3 stuff, which looks much more complicated, but basically, vector addition, subtraction. Make sure you can do the graphical method, which is doing tip to tail. So in your case, you're going to look at a picture and say, which picture is doing correct graphical addition? Make sure then you can use the analytical method. The analytical method you convert into x coordinates and y coordinates. We call that resolving into components. So you have 10.5 meters at, couldn't decide which way to write it, at 30 degrees east of north. I draw my picture and draw it. There's my 30 degrees. There's my 10.5 meters. And then I say, okay, let's break it into x and y. So I'm going to draw x and y separately here. So I define x and y with x being east and y being north. And then I say, okay, which part of this vector, if I take this vector and I break it up into two pieces that are perpendicular to each other, one parallel to y, one parallel to x, I'm going to draw a parallel to x and parallel to y from the tip. I drew both. I could choose either of the two triangles I've now made to resolve. Which one would be the obvious one to choose? The one with the angle in it. So if I choose the one with the angle, my x coordinate is which part of that triangle? Opposite. And so I would say, since sine of theta is opposite over hypotenuse, then opposite equals hypotenuse times sine theta. So that means that my x coordinate is equal to 10.5 meters sine of 30 degrees equals 5.25 meters. So that's my x coordinate, and my y coordinate. The y-coordinate here is the adjacent side. And so which trigonometric function relates adjacent with hypotenuse? Cosine. And so I would have my y component is 10.5 meters times cosine of 30 degrees, which would be like, let's say between friends, 9 meters. It's in that ballpark. 8.66 times 10.5. That's actually really close to 9. So make sure you can do that to resolve vector into components. So you might have a problem that asks, gives you 2 vectors and asks you what are the components of the final answer. So you have to have the x component and the y component. Independence of motion, we've already talked about. Horizontal and vertical, completely separate. Be able to solve projectile motion problems. Here are steps for vector addition. Select a convenient set of mutually perpendicular coordinate directions. Break the vectors into the components. Add the like components. Use Pythagorean theorem to find the magnitude of the result and use tangent to find the angle. Boom. And here's the second problem I'll come back to. Final thing before I start working problems is what exactly are you going to see on the exam? If you look at the exam from last year, it will be very similar except for the last section. The last section, instead of giving you the answers, you will have multiple choice. So you'll have 10 multiple choice or matching questions. Matching questions will look like additional questions. So while, it'll be like 5 through 7. Match the following. And then you have 5, 6, 7, and then you have your different definitions for A, B, C, D. So it will show as more like, say, 15 questions because of the matching showing as multiple questions. And each one of the matching does count as 1 point. So somebody could say, well, that's really 15 questions. Think about it how you want. I just want to make sure it's clear what it is. So those will be things like on units. The ones we had, what is the unit for time, for instance? The scientific method, significant figures on what a vector means, what a scalar means, identifying what's a vector versus what's a scalar. On understanding the kinematic equations. We won't be doing a problem with kinematic equations here, but just on understanding what they mean. And once again, understanding concepts of 1 and 2 dimensional motion, not doing any problems in this section. So this is just knowledge. And that's 25% of your grade. Then you have application section, which is 5, what I call straightforward problems. A problem where you're given, this is the initial speed, this is the acceleration parallel to that speed. After 10 seconds, what is the final speed? Right, that's a fairly straightforward application of a kinematic equation. That's the kind of thing you should see in the application questions. And once again, it could have, break a vector into components or something like that. Now doing the actual work. Something with kinematic equations, 1, 2 dimensional motion. Finally, the synthesis. 40% of the test is in just 3 problems. And these problems will require multiple steps and ideas. The synthesis idea, well, what synthesis is you're taking your knowledge and you're applying it to something new. So in theory, these won't be a problem like you've seen. Now, they'll be very similar to ones you've seen, but not exactly the same, hopefully. So that you can take your ideas and apply them and make more than one idea fit together to get to the answer. Yeah.
So because you're not basing it off of work, technically it's either we get the right answer or we don't.
That's right. And so this will have, one problem will definitely be with vectors. One problem will definitely be with 1 or 2 dimensional. Well, one problem will definitely be 2-dimensional motion. I haven't decided what the third one will be.
So when you say multiple steps, then we're solving for multiple things to get one thing?
Yes.
Okay.
Yeah. So you're asked for one answer, but you can't just do one calculation and get that answer.
Yeah.
James.
I know we had a problem with like the quarterback throwing the ball and he was also moving back.
Yeah.
Will it be that type? Like,
That would be the type of question you'd have in the synthesis, yeah. Because you had to put in 2 different ideas together. All right. I only got 5 minutes.
Because I remember you did solve that one for us and you thought that was really complicated, complex.
Well, it was complicated not because of the quadratic so much as because you had the 1 over cosine squared that you had to convert into, what was it, tangent theta plus 1?
Sure.
Or tangent squared theta plus 1, yeah. That was the part that made it more complicated than using the quadratic in tangent theta. And so I'm not going to give you one where you have to use quadratic tangent theta. You could have a problem where you need the quadratic. And I may or may not have, I'll try to just put it on the equation sheet, right? Because you don't have to have it memorized. You just have to be able to use it. Yes, Kate?
There will be trigonometric identities be on it?
Yes, yeah. So you have sine, cosine, tangent, law of sines, law of cosines, Pythagorean theorem.
We have like cosine over 1 over cosine equals.
Yes, yeah.
Do you have to memorize or email?
Hey, what?
Will we have to memorize the?
No, you'll have that. You as it stands right now, and this is, I'm pretty certain without having the quadratic, the equation sheet is available here. Chapter 3. Notice we have student sample test. Don't remember what that is. Exam 1. Exam 1 equations. That should be with the addition. I'll go ahead and put the quadratic on here, but this should be the sheet you have for your equations. So here's your definitions for the trigonometric functions, where it says, notice that O is the opposite, A is the adjacent, H is the hypotenuse. I don't draw a triangle to identify what those words mean. You have to know what they mean. But you have the definitions there.
Will we use the range equation?
No, you won't. Furthermore, you won't have any use for it. It's a special case equation. It's not a generally true equation. Right, so that's why I don't put it there. Question answered? Okay, let us go back and see if we have time to answer a question. So here's a practice problem. This is one-dimensional motion. The ball is thrown straight up. So that straight up is a hot tip to me that's just one-dimensional. So it reaches a height of 3.3 meters above the ground. If the ball leaves your hand at a height of 1.2 meters, how fast do you need to throw it? So what's the first thing you would do? Okay, the picture's already drawn. Don't need to do that. What's the first thing you would do after that? Okay, identify what I know and what I need. So what I know is y initial is equal to 1.2 meters. Y final is equal to 3.3 meters. And then it does not say, but I have this here, that acceleration in the y direction is equal to minus 9.80 meters per second squared. I put minus because it's going down, and by convention, and I should always do this, I'm defining y as vertical, positive up. And so acceleration downward is negative. So I've identified what I'm looking for, and then, or what I have, and then what I'm looking for is v0. So then to solve this, what should I do?
Identify the equation.
Identify the equation. And so in this case, there is one variable noticeably missing. Time. There's one variable I did not write that I should have that's implied. I have the v initial. What's the speed up here at the top? The speed is 0 at the top. It didn't say that. You have to know, oh, it's changing directions. At that point, the velocity is 0. What's the acceleration at the top? It's negative 9.8 meters per second squared. It's still down at that 9.8. So the equation without time, so there I've written the equation. V final squared is 0, so I'll throw that in right away. So And y final minus y initial, I'm going to do the math in my head to save space. That's 2.1 meters. So 4.1 times 9.8, 19.6, 19.6 times 2.1. My time is up. Let's just get this number and go. So that's 41.16. Notice I dropped the my signs on both sides, and then finally you just square root the answer, which I am sure is on this calculator. And you get V initial is equal to 6.416 meters per second. What's my correct answer here? I overspecified my digits. How many should I have? So there I have my answer. And there's part B, how long before it hits the ground, but we don't have time to do that. Have a great day. I'll see you tomorrow. If you have questions, feel free to email me, come by my office during office hours, or even if I'm not during office hours, if I'm in there.